Keeper 8.1, area between two curves. All right, so when we're looking to find area between two curves, we're either going to be trying to look at the figure as top minus bottom, in other words, one shape on top of the other, or the figure is going to be arranged like right minus left. So you have two side-by-side figures that are forming some region. And you'll see it a little bit better when I show you some examples. But again, just keep in mind, when you see one figure on top of another figure, that's going to be top minus bottom. And then if you're looking at it left to right or right to left, it's going to be right minus left. All right, so for our first example, it says find the area of the region bounded by the graphs of f of x equals x squared plus 2, g of x equals negative x equals 0, and x equals 1. So the very first thing that we do for all of these examples is we start by graphing the examples. So I'm going to graph the first curve of x squared plus 2. Now remember, x squared is just a parabola, and the plus 2 is simply moving it up 2. So I'm going to graph, again, normally by hand, but because I'm doing it on the video, I'm just using decimals. But you're going to graph by hand x squared plus 2. Now on the same grid, we're going to graph the next function, which is g of x equals negative x. So remember, negative x is a linear function that goes through the origin and is sloped down with a slope of -1. All right, so I have something that looks a little bit like this. All right, so the last two functions that we need to graph are x equals 0 and x equals 1. Please understand that those are going to be vertical lines going through the x-axis, through 0 and through 1. And so there I have, you can barely see my green line through 0, and then I have a purple line through 1. Once you have all of your regions or all of your functions graphed, you're going to shade in the area that all the regions touch or all the regions enclose. So when I shade that in, I get something that looks like this. All right, so when I look at this, I see that I have bounds from 0 to 1 on the x-axis, and I see a function x squared, which is on top of the function negative x. All right, so when I think about how I'm going to find the area, I'm going to do top minus bottom. All right, so I have the integral from 0 to 1, because that's my left and right bound, of my top, which was x squared plus 2, minus my bottom, which was negative x. Simplifying this out, I get the integral from 0 to 1 of x squared plus 2 minus, or plus x dx. And then I integrate. So I get x cubed over 3 plus x squared over 2 plus 2x from 0 to 1. Now, if you remember how your fundamental theorem of calculus, you know you guys plug in your top minus your bottom bound. So I plug in the 1, which I get 1 cubed over 3 plus 1 squared over 2 plus 2 times 1 minus plug in the bottom, which would be 0. All right, simplifying that out, I get 1/3 plus 1/2 plus 2. And then cleaning that up, my final answer would be 17 over 16. All right, so for the next example, we have find the area of the region bounded by the graph of f of x equals 2 minus x squared and g of x equals x. So again, just like before, I'm going to start by graphing. So graphing f of x, we know that that's a parabola face downwards because it's negative, and the 2 tells me to go up 2. So I have something like this. All right, g of x equals x is just a linear equation going through the origin with the positive slope of 1. So I end up with something like this. Now notice that these two graphs do intersect each other at x equals 1 and x equals -2. We do have those intersection points, and so we need to kind of identify that because we need to know where to bound our integral from. All right, so again, when I look at this, I want to ask myself, well, is it a function on top of another function, or is a function sitting to the right and the left of another function? And so this, I definitely see a function sitting on top of another function. And so I'm going to do, again, top minus bottom. All right, so when I do top minus bottom, again, I'm going to do the integral from my bounds of my bounds of -2 to 1. Because that, again, that's where my intersection kind of stops. So from again, right here at -2 to 1. And then I'm going to do top minus bottom, which would be 2 minus x squared. That was the top function minus the bottom function of x. From there, I simply integrate. So 2x minus x cubed over 3 minus x squared over 2 from -2 to 1. Plug in my bounds. So I plug in the 1 first, and then I subtract that from the bottom bound. Then I simplify, I get 2 minus 1/3 minus 1/2 plus 4 minus 8/3 plus 2. And then simplifying that, I get 8 minus 3 minus 1/2 to give me a final answer of 9/2. All right, so the next example, it says find the area of the region bounded by f of x equals sine of x and g of x equals cosine of x. And they want us to find the area for only one of the repeated regions. Remember, the graphs of sine and cosine do go on forever, so I don't want to do the whole function out to get an infinite type answer. But if I do just one of my repeated regions, I should be able to find that area. So again, just like in the previous examples, I'm going to graph my functions. So I start by graphing sine of x, and again, just remember from your pre-calculus class, sine starts at 0, goes up to 1, back to 0, down to -1, back to 0. And then I'm going to graph my cosine function. And so remember, cosine starts at 1, goes down to 0, then down to -1, and then back up. And so you can see that I have a region that's intersected by these two graphs. And so that region I have colored in green. All right, so again, when I look at this problem, I'm asking myself, is it top minus bottom? Is it a function on top of a function, or is it right minus left? And so again, when I look at this, I see top minus bottom. I see like this sine wave on top and then the cosine wave on the bottom. And so again, I'm going to do top minus bottom. Now, with top minus bottom, again, I kind of need to know what these x values are, where they meet, where the graphs meet, where, in other words, what the endpoints of the enclosed area is. And so I know that those endpoints, again from pre-calculus, are pi over 4 to 5 pi over 4. And so pi over 4 to 5 pi over 4 is my bounds for my integral. And then I'm going to do top minus bottom, so sine of x minus cosine of x. All right, so integrating that, I get negative cosine x minus sine x from pi over 4 to 5 pi over 4. Plug in my top bound and then subtract that from my bottom bound. I get negative cosine of 5 pi over 4 minus sine of 5 pi over 4 plus cosine of pi over 4 plus sine pi over 4. Then using my unit circle, I'm going to get root 2 over 2 4 times basically. And so I end up with a final answer of 2 root 2. All right, so for this next example, we have find the area of the region bounded by the graph of x equals 3 minus y squared and x equals y plus 1. Now, the first graph, we have to recall from, again, pre-calculus, that's a conic. And it's not just any old conic, it is a parabola because we have one thing that's squared and one thing that's not. Because it's an x equals equation, I know it's going to be a right or left facing parabola, but because the y is negative, I know it's a left facing parabola, and it's going to start at 3. So graphing that, I would get something like this. All right, and then I need to graph x equals y plus 1. And so again, I'm going to rewrite it just so it's easier to graph. So I'm going to write it in terms of y. So y equals x minus 1, which is a linear equation that starts at -1 and slopes up with a slope of 1. All right, so we get something that looks like that. All right, so again, I'm going to shade in the region that is intersected by the two graphs, and I get this red shaded region. Now, when I look at this, again, I'm asking myself, is it a function on top of a function, or is it a function to the right and left of each other? And so I see a function to the right, which is this parabola, and then a function to the left, which is the linear. And so when I do this problem, I'm going to do right minus left. And so when you do right minus left, you want to know y bounds. So I want to know like the lower to the higher bound. So it's going to go from -2 to 1 of my right function, which is the parabola 3 minus y squared, minus my left function, which was y plus 1. Distributing in my negative and adding my like terms, I get negative y squared minus y plus 2 dy. And then integrating that, I get negative y cubed over 3 minus y squared over 2 plus 2y from -2 to 1. And then plugging in my bounds and simplifying, I get negative 1/3 minus 1/2 plus 2 minus 8/3 plus 2 plus 4. And then simplifying that a little bit more, I get a final answer of 9/2.